Another thing 3.1 covers is what is a polynomial function and what isn't. So I'm going to put a whole bunch of different functions here. We're going to have to decide which ones are polynomials and which ones aren't. And then after that, maybe we can come up with a bit of a definition of what's a polynomial. Okay, so here's a big list of functions, some of which you've seen and graphed before, others you may have never seen anything like it before. That might be a hint in some cases of ones that aren't polynomials. So some rules for polynomials are as follows. If I write a real general type of form of polynomial here, we've got, looks quite ugly, f of x equals an x to the n plus an minus 1 x to the n minus 1 plus dot dot dot. There could be lots and lots and lots of terms in there, all the way down to a2x squared a1 x to the 1 and a0 x to the 0, which just ends up being a constant. All the a values are real numbers. So a0 or a0 all the way up to an are real numbers, meaning basically any number you've ever run into in high school or junior high or elementary math would be allowed there. So decimals, fractions, positives, negatives, square roots, all of those would be just fine for the coefficients, for the numbers. Now n, on the other hand, has to be not just a real number, but n has to be a whole number. So if you remember what a whole number is, anything like 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So no negatives, no decimals, no fractions. So let's take a look at these polynomials and decide which of them are, all these functions, and decide which ones are polynomials. The first one, straight linear function. The a values are both real numbers, 3 and 5, that's fine. N is 1, meaning the highest power, the only exponent on an x is 1, so that definitely is a polynomial. So linear function we saw in one of our previous examples is definitely a function. The next one I tried to trick you with this root 2, but root 2 is still a real number. All the exponents are still whole numbers, so we're still looking good, still polynomial. The next one, I threw an x up here as an exponent, meaning the variable is an exponent. That's called exponential. That's not polynomial, so I'll just write a little note beside here. This is not a polynomial function. The next one, we've got a fraction, but the fraction is just a coefficient, which is still a real number. It's not in the exponents. The exponents are just 3, 2, and 1, and 0, so this one is a polynomial function. The next one, the exponents are fractions, which means that they're not whole numbers, so the answer is no, that one's not a polynomial. This next one is a radical function, as we saw in chapter 2. Same thing as x to the 1/2, not a polynomial function. The next one has a negative exponent, not a polynomial function. The next one has a lot of terms here, x to the 5, x to the 4, x to the 3, x to the 2. All of those are whole numbers, no problem. All the coefficients are real numbers, so this is a quintic, fifth degree polynomial. The last one at the bottom, we've got this 1 over x, which means that this is not a polynomial. That's the same thing as x to the minus 1, so the answer here is no. So one thing definitely on a diploma exam they can ask you is, what's a polynomial and what isn't?